Hello everybody, especially my students. In today's video I'm gonna explain you again how to sketch the quadratic function in absolute value or with absolute value when it's placed like on the linear term. So we will be trying to sketch the graph of the function which is defined by this equation. So y equals absolute value of x squared minus 2x minus 8. Then we will try to sketch the graph of the function given by the equation x squared minus 2 times absolute value of x minus 8, and the last function we'll be sketching is the function given by the equation y equals absolute value of x squared minus 2 times absolute value of x minus 8. I'm gonna show you and explain how you can sketch these three functions by using two types of techniques. And the first technique will be by using the translation of the graph of quadratic function, and then by the algebraic explanation of the absolute value. As you already know about from the topic when we were sketching the graph of the linear function with absolute value. So let me start with the first function, which is defined by the equation y equals absolute value of x squared minus 2x minus 8. And in this case, the first approach I want to show you is to use the translation of the graph or of the function which is defined. So let's have the function defined by the equation y equals x squared minus 2x minus 8, and you already should know that the translation or transformation of this function can be defined like, let's say there is a new function g of x which is defined as the absolute value of the function f of x. So to do so and to use the translation of this function, we prefer and we want to sketch the graph of the function without the absolute value, and for doing so we need like 4 points if they exist. The first point is the vertex, which is the very important point of the graph of the quadratic function, which is the vertex where the parabola changes its behavior from increasing to decreasing or vice versa. The next point is the intercept with the y-axis, and then there are two more points which are the intercepts with the x-axis. So there is px1 and there is also px2 for this function. And this is kind of a reminder how you can find these 4 points for the given function written here. And if you have a look on this equation, the only thing we can say now about the parabola is that it's gonna be convex parabola, and we simply can define the intercept with the y-axis because we know that the x-coordinate of the intercept is going to be 0, and we can read the y-coordinate of this point directly from the standard form of the quadratic function, which is coefficient c, which in this case is -8. So the intercept with the y-axis is 0 and -8. The next thing we can do quite easily is to define the x and y coordinates of the vertex. But in this case you have to remember that the x coordinate of the vertex can be calculated by using the formula negative b over 2a, which is in this case equal to negative b is number -2 over 2 times 1, which is equal to 1. Okay, because -2 times -1 is 2 over 2 is 1, so the x in the coordinate of the vertex is 1, and the y coordinate of the vertex can be calculated very easily, and we can do it like we will find the value of the function for x being equal to 1, or you can remember the formula, which I don't remember and I prefer to calculate it very easily. So it means it's gonna be 1 squared take away 2 times 1 minus 8, which is equal to 1 take away 2 take away 8, which is equal to -9. Okay, so our y coordinate of the vertex is -9. We have these 2 points now of the parabola, and it's quite a clever idea to calculate the intercept with the x-axis. So for doing or for finding these intercepts, we know that their y values are equal to 0. So it means we have to solve really like simple quadratic equation, which is x squared take away 2 times x minus 8 is equal to 0. You can do it like in 2 ways. In this case I prefer to do the factorization, which means I have to find 2 numbers, so that if I add them up I will get -2, and if I do multiply these 2 numbers I will get -8. So the question is what are these numbers, and the answer is very simple. You just do -4 plus 2, which is -2, and -4 times 2 is equal to -8. So this equation can be written by factoring as x minus 2 x minus 4 times x plus 2 is equal to 0. You can do the check by your own. So it's gonna be x squared plus 2x take away 4x is -2x, and -4 times 2 is equal to -8. So based on this information we know that the multiplication of 2 numbers, or let's say in this case of 2 expressions, is equal to 0 if and only if one of them is equal to 0. So x minus 4 must be equal to 0, or x plus 2 must be equal to 0, which means x must be equal to 4, or x must be equal to -2. So my coordinates of the intercept with the x-axis for my given quadratic function are -2 and 0, and the second intercept has the coordinates 4 and 0. So let me just erase my calculation here, because I will use this space for sketching the graph and explaining the stuff around. Based on this information, we know that the graph of this function should look like this. This is the x-axis, this is the y-axis, and my vertex has coordinates 1 and -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here is my vertex of the parabola. Now I would need the y-intercept, which is 0 and -8, okay, and then I would need the intercept with the x-axis, so it's gonna be -2, which is -1, -2, and 1, 2, 3, and 4. So these are my two intercepts. Let me now just to try to sketch the parabola quite properly, which looks something like this. Okay, this is quite nice. And based on this information and using the translation of the function, which is, now we put this red line into the absolute value, and you should already know that what this transformation makes with our function. It simply will reflect this part of the graph or this part of the parabola to the positive numbers, so it will come something it will come up something like this. But let's do it like more precisely, which means we need now, as we already know, the parabola will be reflected over the x-axis, especially the negative part or negative values of the parabola. So what is going to happen, the only and the main thing to sketch the parabola properly, or not the parabola, the graph of the function, it means we have to flip the vertex over the x-axis, so suddenly 1, 2, 3, 4, 5, 6, 7, 8, 9, so the vertex coordinates will change. As we already know, the absolute value makes from the negative numbers the positive numbers, okay? So our new vertex coordinates then would be 1 and 9, and what will also change is the coordinate of the py intercept, which will be changed to 0 and 8. Okay, so these are my two critical points to sketch the graph really properly, and the intercepts with the x-axis will remain on the same place. So let me just finish this graph. Here we go, and here we go. So the graph, this part of the parabola will remain the same, okay, because these are all the positive values, so all the positive values will remain the same. So let me sketch this part of the parabola. Now this part of the parabola, as I explained before, will be reflected over the x-axis, and it will become something like this, okay. And this part of the parabola of, let's say, like parent function but quoted, will also remain the same, so it will look like this, okay. So this is our graph of the function, which is defined by the equation y equals absolute value of x squared minus 2x minus 8 and of the absolute value. So this is one way how you can sketch the graph of the function. Another way how you can do it is by the algebraic explanation of the absolute value. Let me just take this function here to the blank space, and it means, by using the knowledge about sketching or understanding the linear function with the absolute value, you need to define how the function behaves when the expression of the values of the function are positive or negative. Basically, very basic information, if the absolute value of x is equal to x, this is happening if and only if x is greater or equal to 0 and it is equal to negative x if and only if x is less than 0. To do such or to use such a definition, you have to find exactly, if you said 0 points, you have to find 0 points and then you have to express the expression in the absolute value for the specific, let's say, intervals or x values. So in this case I will use already the information. What are the 0 points of this function? And if you said these are our intercepts with the x-axis we have calculated before, you're right. So 0 points are -2 and 4. As we already know, these two 0 points will divide or split our real numbers into couple of parts, which in this case will be and now I'll keep going. For each x of from the interval from -infinity to -2 union 4 to the infinity. Why is it so? Because if you think about this function and you find these 0 points, you can say that the function x squared minus 2x minus 8, and you sketch the graph, let me use this one here, it would mean that from -2 to the left and from 4 to the right the function is positive, and on the interval from -2 to the 4 the function is negative. Why is it so? Because as you can see, this part of the parabola is under the x-axis, so the y coordinates are negative, and for this part of the parabola the function is positive, and you can see what is it going to. This part of the parabola is positive. That's why the expression on the interval from -infinity to -2 union 4 to the infinity, our parabola or the expression or the value of the absolute value will be defined by y equals x squared take away 2x minus 8. Okay, and if we think about this part of the parabola, which is from the interval -2 to 4, then our function or the absolute value is defined by the expression or the equation y equals -x squared plus 2x plus 8, which is equal to negative, okay, you can see here, negative x squared minus 2x minus 8, which is of course equal to this expression or to this function. So basically what are we supposed to do now is to sketch like two graphs. The first graph will be representing this parabola, and the second graph will be representing this parabola. Okay, so let me explain this and let me do this, and then I will make the conclusion. So for the first parabola, and I'll be using the red pen now, it means that our vertex coordinates are, and as you can see, this one is really the same as we were using in the first explanation, explanation. So we already know all the information, which is vertex coordinates are 1 and -9, py has the coordinates 0 and -8, px1 has the coordinates -2 and 0, and px2 has the coordinates 4 and 0. Okay, we already know how the graph of this red parabola looks like. Let me sketch it again. So it's 1, let's say here is -9, here is, oops, let's use some reasonable scale. Here is 1 and -2, 1, 2, 3, 4. So these are my points for my parabola. We have already sketched, oops, this is kind of really challenge to do the parabola properly, and it looks like this. But as this is really now defined only on this interval, we will keep in mind or take only this part of the parabola, okay, the blue part of the parabola. Now let me explain how the function behaves for the axis from the interval -2 to 4. And to sketch the parabola, we really have to find the coordinates of the vertex, which are, and let me just calculate it for you, -b over 2a, which is equal, -b is 2, and 2 times -1, which is equal to 1. Okay, so the vertex coordinate is 1, and now we will look for the value of the function for x being equal to 1, which is -1 squared plus 2 times 1 plus 8. As you can see, this is equal to -1 plus 2 plus 8, which is equal to 9. So the vertex coordinates are 1 and 9. Okay. Now, you should understand that px and px1 and px2 are the same as here for the previous function. So this is gonna be -2 and 0, and px2 is gonna be 4 and 0, and py can be read directly from the equation of the quadratic function, which is 0 and 8. What I'm gonna show you is that if you sketch this function like on the whole domain and you don't consider the interval you are looking the graph of the function for, it would mean that if here is number 1, and let me put it a little bit higher, here is 9 for the y, and here is 8 for the intercept, and let me just put here points 1 and -1, -2, 1, 2, 3 and 4. Now if you would realize the graph of this function, these are the critical points of this function, and if you sketch the function now, it will look like this. Okay, but you have to keep in mind that now the function is defined only for this axis from -2 to 4, which means only this part of the parabola represents the function in absolute value, which means this one. Okay, so this is like the behavior of the function on the first interval, and this is like the behavior of the function of on the second interval. So if you put these two, and in this case these two cases, and especially these two blue lines, though this one is interrupted, in one chart, you will get the same graph of the function as we found by using the transformation of the function, which is here. Okay, let me just try one thing. Basically, it would mean if you take this part of the graph and you move it here, oh, okay, it doesn't work very nicely in the paint, but let me do it a little bit like this. So if you take this part of the function and you move it here, you can more or less see that the function's behavior or the graph is really like we found when we used the translation of the function. So you can now understand and see very clearly what is like strong knowledge and really something to use is the translation of the function. And if you realize that to sketch the graph of the function, in this case quadratic function, this one, and if you put this into the absolute value by using the translation, you can very easy find the graph of the function without applying any of this algebraic stuff we have been using in the second approach. Okay, now let's go to the second example, and let me do the second example. I'm sorry, vice versa. And the second example, or the second function, I'm sorry, I need to clear this one because I'm quite sure I will need this space as well. And in the second example, let me explain and sketch the graph of function given this way. In this case, you can also use the translation of the function, but I'm like a little bit more sure that it's a clever idea to explain this one like another way around. I'll use the algebraic explanation, which means that we'll be sketching the graph of the function y equals x squared minus 2 times absolute value of x minus 8. In this case, you should probably know, and you can find very easily, that our 0 point is equal to 0, and let me just write it this way: x is equal to 0, and then it means that our function for each x from the interval negative infinity to 0 will be defined by the equation y equals x squared minus plus 2x minus 8, and for each x from the interval from 0 to the infinity, our equation will be defined as y equals x squared minus 2x minus 8. Okay. What I want to show now is that if you use this approach, then it would mean that you should still find the intercepts and vertex coordinates. So let's go through the first function, which is this one, and the vertex coordinates are negative b over 2a, which is negative 1, and the second, the y value is negative 1 squared is 1, plus 2 times negative 1 is negative 2, which is negative 1, negative 8, which is negative 9. Okay, the py intercept has the coordinates 0 and negative 8, and px1 has the coordinates, we will calculate, we will find out, and px2 has the coordinates, we will find out. Okay, but we were already solving this equation, I think, and the coordinates of these equations, or the intercepts, are negative 2 and 4, which is negative 2, 0 and 4 and 0. Okay, so the graph of our green function looks like we already know: negative 1, negative 2, positive 1, 2, 3 and 4, and here is -8 and here is -9. So the graph of the green function, -1 and 9, here is the vertex, here is the y-intercept, and -4, I'm sorry, and not -2 plus, but 2, which means the graph of our green function should should look like this, and it goes to -5, -4. Okay, so here is -4, but as we can see, our function is defined from the -infinity to 0, which means we consider only this part of the graph. Okay, we can forget about the rest. And now let's have a look on the second quadratic equation or quadratic function. The vertex is 1 and -9. We already know why. Py is 0 and -8. Px1 is equal to -2 and 0, and px2 is equal to 4 and 0. You can find out why and where does it come from. And the parabola or the graph of this function will look like this. So vertex is 1 and -9, py is in -8, and this is 1, 2, 3 and 4, -1, -2. So the graph of the second function looks like this. Okay, here is the vertex for 1 and -9, and in this case we just have the function which is defined on this for this axis, which means from this blue parabola we will take only this part of the parabola. And now if you have a look on these two graphs and you think about it, you can really very easily sketch what the result or what the function should look like. And if you think that these are only this red part of the parabolas, you're right. So let me just sketch -1, 2, 3 and 4, 1, 2, 3 and 4. Here is -8 and -10. So the final parabola will look like this, or the final graph, sorry, because it is not parabola, will look like this. As you can see, this is this part of the parabola for axis being less or equal to 0, and this part of the parabola for axis being greater or equal to 0. That's why the graph of the function defined here looks like this. This is one way you can do it, though in this case, again, this is something which is really not very easy, and it's quite complex, and it requires a lot of let's say skills. But as you already know, the second approach you can take is the translation of the graph. So the second approach is the translation of the function, and our translation here would be f of x, okay, which is defined by the equation x squared minus 2x minus 8. We already know how to sketch this graph, and the translation is the function g of x, which is defined like f of absolute value of x. So in this case, it is enough to sketch this graph which we already know the graph looks the graph looks like this. I have done this couple of times. So this is the graph of f of x. Okay, I will use this. So this is f of x, the black line, the black line or the black parabola here. Okay. And now, if you think about what this transformation or translation of the graph does, it is the reflection over the y-axis. What does it say? We already know that to do the reflection over the y-axis, you take this part of the parabola and you do reflect it over the y-axis, which is this one. So the procedure is, if you would put mirror here instead of the y-axis and you look into the mirror from this side, what would you see? Yes, you were right. You would see something like this. So here is 1, 2 and 3 and 4, here is 8 and 9, so here is the vertex, so here is our parabola. And if you have a look into the mirror, you will see 1, 2, 3 and -4, the same vertex. The reflection is like this, and you will see something like this. So you can see very easily that it really makes sense to know how to use the translation or the transformation of the function, because here is our first function, okay, and here is our second function. And what did we do? We just reflected the first part of the graph over the x-axis, over the y-axis. Okay, and now I'm not gonna explain how to do this one, because if you combine all the things we have discussed and you just simply, let me just write you the hint, if you just use this, if you want to sketch the graph of this function, if you want to sketch the graph of this function, how can you do? It's very simple, because you already know how to sketch the graph of the function which is defined by the equation y equals x squared minus 2 absolute value of x minus 8. Which graph is it? What graph is it? Exactly, it's this graph. And if you would apply the transformation, which basically means you would put all these the whole expression into the absolute value, what will happen to the graph of this function? Yes, the whole part which is under the x-axis, which I just highlighted by yellow, will flip or reflect over the x-axis, and the graph of this function will then look something like this. Okay, you can try by your own, and the best idea or the best behavior how to verify my conclusion and how you can find out very easily is to use the graphical tool, for example Desmos, and in this case I'm gonna provide you with the print screen from this super special tool, so that you can see what I really meant exactly is you can get the graph like this. Okay, so the green one is without the absolute value, like the general absolute value, and the purple one is the one we were trying to sketch. I know this video is quite complex, so maybe you need to watch it like not only once, but maybe 3 times, 4 times, it depends. And if you would have any questions, feel free, and you can ask me during our next lesson, which is gonna be very soon. Thanks for watching, and have a nice day.